This is a video on Lagrange multipliers. The question states, maximize f of xy is equal to x plus 2xy plus 2y, subject to the constraint x plus 2y equals 100. So let's recall that Lagrange multipliers says that if we have a function f subject to a constraint, then the relationship for the maximum is that at the maximum, the gradient of that function will be equal to some constant lambda times the gradient of the constraint function. So let's find the gradient of our f and our constraint. So first, the partial derivative of f with respect to x is 1 plus 2y. And the partial derivative of f with respect to y is 2x plus 2. And then the gradient for the constraint equation is 1 comma 2. So that gives us the vector 1 plus 2y comma 2x plus 2 is equal to lambda times 1 comma 2. I can look at the first components and set them equal to each other and get that 1 plus 2y equals lambda times 1, or lambda. And the second components give us that 2x plus 2 equals lambda times 2, or 2 lambda. So I can divide the second equation by 2 to get rid of all those 2's, and I get x plus 1 equals lambda. So there's lots of ways of proceeding at this point. What I'm going to do is say, well, if lambda is 1 plus 2y, and lambda equals x plus 1, then 1 plus 2y is equal to x plus 1. And then I can cancel the 1's. And what I get is that x is equal to 2y. So now let's put 2y in for x in the constraint equation. And that gives us that 2y plus 2y is equal to 100. Or 4y equals 100, so y is 25. Well, x is 2y. 2 times 25 is 50. So x is equal to 50. So now I can just plug into the function. If I plug in 50 for x and 25 for y, I get that the function evaluated at the point 50 comma 25 is equal to 2600. Notice that this is a maximum. Had this been a minimum, then that would mean that this would be the smallest number we could get. But clearly if y is 0 and x equals 100, for example, then f is just 100, which is much smaller than 2600. So this is indeed a maximum. And I'm done with the problem.